Okay, just checking to see if I got the recording going here. And I do. Okay, so we'll go ahead and start. I think the Chapels are traveling this week and Valor is on his way back from an appointment. So right now it's just me. I want to make doubly sure I'm recording so that y'all can watch it later. Not a lot on the agenda today, just a few homework problems. I would have had you guys work these if people have been in class, but I want to make sure they get in the notes one way or the other. So I'm just going to go ahead and work them just as a review of last time. And then we're going to try to just plunge through 6.7 today. And that is the end of, I want to be extra clear here. I was probably calling it the end of factoring last time. The end of new factoring techniques or methods. It's not the end of factoring, because once we know how to factor, we have to keep factoring. Chapter 7's got a lot of factoring in it. But 6.7, today we will end the new factoring methods. We'll end what you need to know for that. Now, because things are getting chaotic and people are traveling, we're going to have to just suspend all quizzes till after Thanksgiving. So what'll probably happen is over Thanksgiving, I will prepare the worksheet and be ready to go to get that in your hands as soon as possible, because after Thanksgiving, we have a hefty review of factoring ahead of us. And then we have one extra section, 6.8, where we start applying factoring in order to solve problems. So talk more about that, but there's nothing really you need to worry about over the holiday. Basically, just aim to accomplish the homework that I will assign for 6.7 to kind of get that out of the way prior to the holidays kicking in full force, if at all possible. Okay, so let's look at, and this is 6.6, number 5. And at the beginning of class last week, or feels like last week, the beginning of class on Tuesday, we learned that when you are dealing with factoring something that looks like this, meaning it's a trinomial, it's a 3-term polynomial, if that lead coefficient is 1, you can actually get away with a shortcut. Instead of taking this and expanding the 10x into 2 other terms, turning this problem into factor by grouping, essentially, you can really just focus on factoring this number right here, the last number, negative 24. And so because it's negative, we know we can factor it a couple of different ways. We could either factor it like that, or we could factor it where the 1 is negative. And of course, that would, if we were going to be really, really just thorough, but not pay attention to the rest of the problem, we could complete both of these lists all the way down. But kind of keeping our brains turned on, notice that the first list, if I add my pairs of factors, in each case, I'm going to get a negative number. And that's not helpful, because what I need to get is a positive number. I need to get a positive 10. So I am going to completely disregard this first list and turn my attention to this second list. And as luck would have it, I've actually gotten the right pair of factors here, because negative 2 plus 12 is 10. So that's great. Now, if the lead coefficient here had not been 1, so I'm going to put in the notes, first of all, what I was just saying, the lead coefficient is 1, so shortcut. If the lead coefficient had not been 1, then negative 2 and 12 would have been the numbers that I was using to break apart 10x into 2 separate terms, so that my whole polynomial is 4-term. But because we're doing this nice shortcut, really all you have to do, once you have those 2 numbers, you are done with the problem. You insert those 2 numbers into your parentheses, and you're good to go. Okay, and you can verify that by multiplying back that you will get x squared plus 10x minus 24. If shortcuts are troubling to you and you would rather just take one way and use it all the time, the class notes from Tuesday show how initially I treated this type of thing as though it were not a 1, as though it were a 2 or 3 or 4 or something else, multiplied it by the negative 24 and just went the whole factor by grouping method. Okay, number 11, kind of kicking this up a notch. What if we have a polynomial that just looks all kinds of messy at first because it has an overall GCF hidden in there? So first of all, because it looks messy, I suspect an overall GCF. And when I look at it, I see that absolutely it's got one. And in terms of the number that might be part of this overall GCF, it looks like 4 is the largest number that divides into 4, 28, and 40. So I pull it out. And then the x's can't participate because the final term doesn't have any x's. So it's impossible for the x's to have been a common factor of any size. But the z's appear in all 3 terms. In fact, they always appear the exact same way. It's always z to the first. So I don't have to think too hard about what I pull out. It's going to be z to the first attached to that 4. Now, when I do pull it out, what's left behind in these parentheses may or may not be factorable. We'll try it and see. So it looks like dividing out the 4, dividing out the z, left me an x squared in the first term, left me a 7x in the second term, and then left me simply the number 10 in the third. So in a lot of problems, this is where we end because the polynomial inside here is not always factorable, but we at least want to ask ourselves, is this factorable? Because very often it will be. Okay, so looking at that polynomial in isolation, I want to try and factor the 10 because I notice, just like last time, kind of in the same little segment of problems here, I have a, let me switch my color. Got a lead coefficient of 1, so that triggers the shortcut. That means I can factor just this 10. That's all I'm needing to factor. And yes, really, because everything's positive here, we only have to look at one list. And that looks like what I'm after. Because 2 plus 5 equals 7, that's great. Okay, so, but before I phrase this thing into its final form, remember, I'm trying to keep myself from forgetting my overall GCF. So that's what that line is for. So I don't want to get too caught up. The polynomial there in the black would have factored very nicely as x plus 2, x plus 5. And then, of course, I had 4z sitting out front. Okay, and then finally, let's see, what was the third problem that I had marked down for us to look at? Number 31. Which I picked because I could see an overall GCF hiding in here, and I figured since Tuesday's class was the first time we had had any meaningful set of problems that contained overall GCFs, we probably needed to refresh on that a little bit this morning. So the overall GCF here is not as interesting as it was in the last problem. It's similar in a way too. It's just going to be, well, let me not say that. It's going to be the number 2. For half a second, I thought that 4 was once again going to play a part in my GCF, but 4 will not divide evenly into 22. So out comes 2. That's the best I can do, is divide 2 out from every single term. So I get a 14y squared plus an 11y plus 2. And just check that when you get to this stage. It's really good to check and make sure you really did get the GCF out of there. And what I mean by that is make sure that you cannot divide 14, 11, and 2 by some other number. If you can, then you know that you got a common factor out, but you didn't yet get the greatest of the common factors out. So looks like that's not an issue here. Okay, so try to factor, no guarantee of success. Excuse me. But we're at least going to try to factor this. So no nice shortcut here. We are going to have to involve the 14. So we've got 14, we've got 2. Again, keeping everything in descending order so that you don't accidentally grab the wrong number. So 14 times that 2 will give me 28. Everything across the board is positive. It is possible to form a positive number by multiplying 2 negatives, but we don't really care about that because all our numbers in the polynomial are positive. So let's see, I have 1 times 28, 2 times 14. 3 won't work, but 4 times 7 will, and in fact, that's the pair that I'm looking for. Okay, because 11 here, positive 11, can be formed by adding 4 and 7. So no nice, cute shortcut here. I do have to expand into 4 terms. So 14y squared, that's good to go, plus 2, that's good to go. But 11y, I'm going to break that apart into 4y added together with 7y. And this is the type of problem where I think we're all at the biggest risk of forgetting this overall GCF of 2. So I'm just going to kind of put my reminder right before the point that I'm going to have to scroll and lose it. So don't forget the 2. As we get kind of caught in the weeds here with factor by grouping. Okay, so factor by grouping, there's always 2 GCFs hiding in there if everything's going according to plan. So it looks like the first GCF will be a 2y, and then there will be some kind of leftovers in parentheses. The second GCF, it looks at first like you don't have one, but remember that you always have a 1. And this is the case where that 1 is super important. We're used to disregarding the 1s. If, for example, our big overall GCF turns out to be 1, we disregard it. But in the middle of factor by grouping, you have to have that 1, or the problem will not work out. And sure enough, pulling out the 1, so-called 7y plus 2 doesn't change. And I've got this, and I've got that. And now is the time when that 2, there it is, it's going to come all the way down. You can add more arrows if you need to. Okay, whatever you need to do to not forget the overall GCF. It's super easy to pull those things out, stick them to the side on your paper, and forget to write them down in the final answer. So it's something I would have to take off a moderate or a minor point value, but every little point counts. So as long as I see that there's the overall GCF is sitting on your paper somewhere, at least I'll know that you've got it out. That's why I can give you some points for it. But we want to aim for not only dividing it out, but also writing it in the final answer. Okay, so 6.7, factoring by special products. And there's some bad news and some good news here. The bad news is some of the things in this section, so I'm going to say 3, and let me be a little bit less vague there. 3 formulas that you absolutely must memorize. There's no way around it. These are not things that can be factored using any of the nice methods that we've learned, because technically we haven't been learning formulas, we've been learning methods, processes. There's 3 formulas you absolutely have to memorize in chapter 6.7. The good news, other parts of this section, not those 3 formulas, but other parts of 6.7 are optional to memorize. If this sounds familiar, it's because chapter 6.7 is the flip side of some of what we talked about earlier in chapter 6. When we were multiplying polynomials before we ever learned to factor, when we were multiplying polynomials, the book occasionally tried to help us out by giving us a formula to memorize. So instead of multiplying these 2 polynomials, you can recognize that they fit a certain formula and just jump to that. And I told you some of that is completely, phone call from South Dakota, I don't know anything up there. That is completely optional, but that there were other things that were not optional. Same thing here when you're factoring, because it's just the reverse of multiplying out polynomials. When you're factoring, sometimes you can get away without memorizing their cute formulas. Other times, you can't. So let's dive in. Let's start with the good news, because not only is it good news, but it occurs first in this chapter. So from what I was just saying, I wonder if they're going to help me out and put I just found a typo in the book. That's great. Recall from section 6.4, the book calls it 5.4, and I know for a fact, because I'm looking at it, and we just did it a few weeks ago, it's in chapter 6. It's all part of chapter 6. If you have something that is like this, x plus 2 times x plus 2, for example, you could write it a little bit more condensed like that. And I'm going to say it fits this optional formula because you didn't need to do this in 6.4 and you don't technically need to do this now. Okay, so the optional formula is the binomial squared formula. Okay, so if that appealed to you in 6.4, what you could have done was recognize that A was X and that B was 2. You could have gotten X squared plus 2 times X times another 2 plus 2 squared. And while that would have still required a little bit of simplification, the benefit, if there is one, is that if you get really good at this, it speeds up the process maybe slightly from you having to multiply, to FOIL piece by piece by piece by piece. Also, so similarly, if you had 2y minus 1 times 2y minus 1 back in 6.4, you could have written it like that. Goodness. Now I'm getting a call from Gulf Breeze, Florida. Thought all of those fun sort of phone calls were going to go away when the election was over, but I guess not. Whoops. Optional. Optional. Formula. No, I don't want to run out of room. The optional formula, a minus b squared. No. Okay, that one's got a negative in the middle. Okay, so being really careful here, because a is actually this whole quantity of 2y. And b is simpler. B is just 1, but we don't want to take that negative as part of b. Notice the formula says a minus b. So the minus is separate from the b. So you have a squared minus 2 times a times b plus b squared. And you simply have to simplify that out a little bit. Okay. So that's where we've come from in 6.4. Now, we're going to be doing the opposite sort of a thing. So we can take those same two formulas and we can use them in reverse order, but they're still optional. Because basically you have to recognize that something is in, something looks like the right side here. And because we're now factoring, instead of me calling it the right side, it's probably good if we flip it around. Because this is what you'll be seeing. So a polynomial in this form or in this form is what you'll be seeing, and you will just recognize that it's so and write it in the more condensed factored form there. So, for example, what have we got? Practice number 1. Thing that we've got to factor is b squared plus 16b plus 64. And the key to recognizing that you've got one of these things is, first of all, you want to recognize that the number there on the end, so step 1, the number on the end is a perfect square. We talked a little bit about perfect squares in class on Tuesday. Perfect square meaning 64 can be written as, there's some magic number that is smaller than 64, that if you multiply that number to itself, you get 64. So 8 is the magic number here. We could say that using terminology that we haven't really talked about yet. We could say that as 64 has a square root. So 8 times 8 is 64. So that's kind of our first clue, because, and the positive version is apparently what we're trying to match here. If this thing is going to work out, we need to be able to write this as something squared plus 2 times AB, plus B squared. So we could rewrite this as B squared plus 16B plus 8 squared. And we've taken the first step. And of course, as I take that first step, I scroll down to the point that I can't see this anymore. Okay. So that means, in terms of who's A and who's B, B is 8. All right, so that means A, and this is so confusing. I absolutely loathe how they do this. In fact, I loathe it so much. I'm gonna do this. This is just really unfortunate that they would do this to us. The problem had B's in it, and I'm going to make them X's because it's absolutely unnecessary to have that. When we're trying to learn a formula with A and B, it's unnecessary. Okay, so apparently A is X. So A is X, so B is, hey Valor. And step 2, just try to make it conform to the formula. So this is X squared plus 2AB, that would be 2 times X times 8 plus B squared. And that all checks out because 2 times 8 would give you your 16. You'd have your X there. So knowing that this will work, verifying that this fits the formula means that we can just hop to that so A plus B squared. Okay, now again, that is totally optional. And Valor, all I've done at this point is, I went over a couple homework problems, but the new stuff that we're learning, I just started the new stuff right up here. And basically, we're doing optional stuff. We are just starting where they start in the book, looking at a couple of optional formulas. If you choose to memorize these, that's your choice. I really wouldn't at this point because there are some things that you must memorize in this section. But we're just kind of looking at how you can use their formulas. Now, all I would do, okay, if you don't want to memorize the formulas, and I usually don't want to memorize anything I don't have to, okay, so if you don't want to use the formula and the X squared plus 16X plus 64, all you would do is recognize that this is one of those nice shortcut trinomials with a lead coefficient of 1. And you would also go about factoring 64 the way we normally would. 1 times 64, 2 times 32. Completely 16, yeah, goodness. 5, 6, 7, 8. And you would get to your magic pair of factors, and they would just happen to be the same number because you're trying to get 16. 8 plus 8 does equal 16. You don't have to care that it's 8 and 8, but that's indicating a perfect square, which is indicating a formula. You can just go about your business and do what you would have done. Got to write my X's. X plus 8, X plus 8. So that is the way I would recommend. is be consistent to what we've been doing. Don't memorize things that aren't necessary to memorize. Okay, so looking at, I think honestly, it's just not productive. We could go on and talk more about those two formulas, but I don't want us to get caught in the weeds and waste time with them. Okay, so that was the optional to memorize section, and it's as we said, it's the same formulas that were optional to memorize in chapter 6.4. So when we were learning how to distribute out to multiply polynomials, we learned there were some polynomials that triggered formulas if you chose to use them. Now that we are kind of unpacking, rewinding those same type of polynomials, we're just unpacking or rewinding the same formulas, but they are just as optional as they ever were. So what I would say is just take them or leave them, but probably leave them at this point. Okay. Now,
yes, sir.
There was bad news here as well. There are 3 formulas in this section that
yes, sir. Unless I may have to.
So I'm going to try and group those together. So the not optional section, the bad news. And I'm just going to throw all 3 of these up.
We'll plan on 8.
You don't have to flip back and forth
Thank you, sir.
looking for what do I need to memorize for this test. So there's 3 of them, and if I put them all 3 up there, you'll be able to see what they have in common, and that might be helpful. Okay, so here's the first one. Here's the second one. And here's the third one. Okay, so notice that they're all either squares or cubes. And they are very similar to each other. There they are. Okay, so notice that they all start with either a minus b or a plus b, and notice that you don't have to worry too much about which one is it going to be in each problem, because it always matches whatever sign was in the polynomial that you're trying to factor. Okay, so all of those things will match. Another good thing about these formulas, these are all binomials. So a clue as to how do you know that we have to use a memorized formula? Well, it's not going to look like what we've been doing. What we've been doing were trinomials, were 3-term polynomials. And these formulas don't work on those type of things, and they're not needed. They're only needed for when you have 2 terms, and the 2 terms are in a very, very specific format. Okay, so this is the bad news right here. This is really the end of the section on factoring. Will be just how do we apply these formulas, and how many ways can the book try to hide them from us? And you can probably tell the top one is the easiest. So that's the one that we'll start with. It's also one that you've seen before in reverse order. Again, in 6.4, when we were multiplying, we learned that if you see 2 polynomials that fit this format, you can jump to the final answer. And we did talk about it a little bit, and I told you guys that it was optional in 6.4, but it will not be optional in the rest of the chapter. And this is that moment where we see that, okay, when we've got something that looks like this to factor, have to use this, this formula, and I guess I should put their names. This is called a difference, meaning subtraction. Difference of 2 squares This is a sum of two cubes because something to a third power is said to be cubed. And then finally, another difference of two, this time of two cubes. All right, so there's a difference of two squares, there's a sum of two cubes, there's a difference of two cubes. And I'll go ahead and put in here because this is a common thing for people to, for teachers like me to do on tests. We love this type of thing. If you see something that's a squared plus b squared, which is a sum of two squares, is not factorable, or it's prime, we could say. So that's good news in one sense because you don't have to do much work, but it's bad news in another sense because it's easily confused with the formulas that do work, that do require factoring. So, but anyway, therefore, if you're a flashcard type of person or you want to have a list of things that you absolutely have to learn for the test, these three formulas will be on it. And for the rest of class, we will just practice them. And the first one, the first practice problem specifically, or maybe even the first several, are going to focus solely on the difference of two squares here. We're going to get really, really good at the difference of two squares before we worry about anything being cubed. So let me write all of these up here because it might be good to compare and contrast. So you can see that they all have two terms. The only formula that we will need is this formula. But there's also that number one rule of factoring. Even though we're moving into new territory, we still don't want to forget to check these for an overall GCF. So that hasn't changed. They're still going to try and hide those things from us. And if you kind of scan down the list, really it's only like these two here in the middle where I would suspect an overall GCF. If you look even a little bit closer, 25 and 49 don't share anything besides one, but 45 and 20 do. 45 and 20 share like a 5 or something. So I'm thinking that part C will be the only one where we have to actually pull out an overall GCF. Okay, part A starts off nice and simple. I'm going to rewrite this so that we can clearly see that this is something squared minus something else squared. So if you write it in that form, then you can clearly see that A is X and B is 4, and that makes less work. From here on out, it's not math, it's just placing the X and the 4 into their parentheses and making sure that they're separated by negative one time and they're separated by positive another time. That's as easy as it gets, and of course it won't stay that way for long. This next problem, we have to start thinking of how, okay, 25b squared, how would I write that in something, in parentheses, as something to the second power? And thinking about square roots, which we haven't had to do, we'd have a 5 and a b, and that quantity together would have been squared to produce 25b squared.
I know. It's
What's
just
better with this one?
And then we've got a minus, and then I guess you don't need parentheses here at the end.
When you get time class.
We've got
same roll.
7 squared. So maybe a little bit harder to see because your A and your B, well, specifically your A is not made up of just one letter or one number.
Just your mouth.
5 and a B multiplied. So a little bit of extra work in the setup can help you out so that towards the end, really, it's just throwing these into the parentheses. I'd say the most common mistake people make in these is saying, well, I see this 25, that must be A or something. 49 must be B, when in reality, no, that's part of A squared, that's part of B squared. So you have to break it down, take
Yeah,
it
they sent it
square
to your
root,
email, man.
do something like that.
RIPJ.
Okay, so I said C was the only one where you have an overall GCF. And another reason that you will need to look for an overall GCF is because 45 is not a perfect square. 20 is not a perfect square. So even though this is a two-term thing, we can't just dive right into that formula. We actually have to pull out the overall GCF or we won't get anywhere.
It's not. It's okay right now. You don't need to.
Let's see, that's going to be
Take a Tylenol.
minus 4
It's not bad right now.
x squared.
You don't want medicine?
There we
No,
go.
not-
Okay.
Not
So
until
when
it
you pull
gets
the 5
worse.
out, you get something that looks like this. And thankfully for us, the 9 and the 4 definitely are perfect squares. 9 is 3 times 3. 4 is 2 times 2. Okay, so with the 5 still out front, I guess I'll keep it
What did you get for breakfast?
color-coded here in green.
I ate.
Let me change these, like I'm always in the habit of doing, change these to brackets so that when I have parentheses in here to make it extra clear, it won't be parentheses piled on top of parentheses. Okay,
That's not even going to month
on the
because we
interior
are
here,
problems on the board.
that's my A. That. So the 3 and the 2x are the pieces of the puzzle that I need to put together into my formula. 5 out front, that has to come along for the ride. But just in terms of it being an overall GCF, not in terms of me plugging it in to my formula itself. So I've got 3 minus a 2x and 3 plus 2x. That, excuse me. And then the last one, it's really not all that difficult. It's just that you've got a fraction. So just like we did with the x squared minus 16, it's on that level of simplicity. It's just, you have to think about the fact that 9 times 9 is 81. And 81 and therefore 9 are denominators. They have to be on the bottom of the fraction. So your A is y, your B is 1 over 9. And there you go. So nothing super complicated there. There are some things they can do, and of course they will do in the next couple of examples, where you're applying this formula, and it's an easy formula, but the problem itself is more difficult. It's harder to identify that, hey, it's just a difference of 2 squares. So we will run through these just to make sure. These are all thankfully pretty quick problems. They're quick, but they're advanced. So it's sort of a weird dynamic. Okay, this looks like 10,000 to me. It better be 10,000, yeah. So there's this one, and then this weird one. And let me bring that formula down.
I have it.
We need it again. A squared minus B squared. We've got something like that. Okay. You see that x to the fourth and you think, well, I don't see a square there. I see a fourth. And that's true, but there is a relationship there that requires you to sort of flash back to what we learned about exponents. And I think on Tuesday, there was a problem towards the end of class that required us to think in these terms. So x to the fourth is x squared squared, because this rule here, when you have one variable raised to two separate powers, requires you to multiply them. That's something we learned early on in chapter 6. And all we're doing now is just sort of creating that situation ourselves, or recognizing that that situation is hidden inside the fourth power that they gave us. And then 10,000, okay, so it's got
Like when
zeros.
Well.
Let me just write this up here. It's 100 squared, because if you took 100 and multiplied it by 100 itself, 2 more zeros would get tacked on, and that would complete your 10,000 that they had. So this one really is a difference of 2 squares, but it's much more hidden than what we had to deal with first. So let me add a little bit of extra to the notes here. That's your A and your B. Now, interestingly for us, when we stick these into the formula, we can't get comfortable at this point because they have actually hidden another one of these problems inside of the first one. This x squared minus 100 is still factorable. X squared minus 100 is x squared minus 10 squared. It is in and of itself another difference of 2 squares. So what's really going to happen to us, we're going to have x minus 10, x plus 10. That will be the format where we can finally leave x squared minus 100. And then x squared plus 100, even though it looks so similar to what we just factored out, that plus sign in the middle makes all the difference, and there's absolutely nothing that we can do to break that down. Okay, so this problem was interesting because there were 2 differences of 2 squares in the same problem. It was still a major clue that there were 2 terms here. That 2 terms separated by a negative are always suspicious. We know they might have done all kinds of crazy things to try and disguise it, but it's still really hard to get away from the fact that there's 2 terms separated by negative. So if at all possible, we want this to turn into a difference of 2 squares. And in Algebra 2, 9 times out of 10 it will, because they're wanting you to practice this skill. So it's just going to start getting a little bit harder to recognize what are A, what are B, what are A and B, I should say, and to know when you're done with the problem. Same thing here. They're just getting really clever. Let me take that 49 and write it as 7 squared. And in an unusual type of a problem, we've got a little addition problem, a little binomial. That's A. And then B is just the number 7. So if we're told to write down A minus B, A plus B, which I will do underneath here so I have a little bit more room, get my parentheses set up. So A minus B and A plus B, and just like part A, I'm not done. When I apply that formula, we can get way too used to applying the formula and being done completely. And they're just finding more and more ways to trip us up because this is not yet simplified. Just really, really basic math rule there. You've got the 2 and the -7. You want to add them or subtract them together. Same thing with the 2 and the +7 there. Okay, now the last one of these, and sometimes I'll say this in the lecture, but this is important, I think, to write down. This is beyond the range of the test, since we're starting to get closer to thinking about testing on these topics. I just want to make sure everybody knows. This is wild and crazy. It's good to know for the future that you can do this, but it's just got too much in it. Okay, so it's worth noting, and another reason this will not be on the test is because we've been taught, and I want you guys to get really good at seeing 4 terms and thinking, is it factor by grouping? So if I try that, which there's never anything wrong with seeing 4 terms and attempting to kind of force it to be that way. But really, I can try. Notice that I'm not getting the matching terms in the parentheses that I need. And I've mentioned in the past, sometimes in more advanced classes, what they've done is scrambled the terms in just the right way so that factor by grouping looks like it won't work. And I haven't yet found a problem. I thought a couple weeks ago that I had found a problem that required that, and it turned out that I was just reading it wrong or doing it wrong. I can try to rewrite the order of those 4 terms any way I can think of. And what's going to happen is that factor by grouping is just never going to pan out for us. So my initial attempt failed. All of my future attempts at rewriting the terms will also fail. And that just means that factor by grouping is not right for us in this case. So what we're going to do is try a different technique. Rewrite that polynomial just the way that they gave it to us. And instead of treating the first 2 terms and the last 2 terms as their own separate problems, I am going to recognize that these first 3 terms are actually something that I could factor. If I broke 9 apart, I would find that 3 times 3 equals 9, and that 3 plus 3 equals 6. So this is one of those cases where you have that. And the book would love for you to recognize that as one of their formulas, but it's an optional formula. One way or the other, you would get to this stage, and all of a sudden, you would notice that this can be A, this can be B, and you can plug into A minus B times A plus B. It's hard to even write it. There's so much going on here. So this is A minus B, and this is A plus B. So it's a difference of 2 squares. It's not an obvious difference of 2 squares. And it is not at all the type of thing that I will be putting on the test because it is so out there, so advanced. Let's see. Like my pen just got bigger. Okay, let's go back to this. Is that what I was using? Yeah, that's what I was using. Okay, so just be aware, there's nice ways that you can use these formulas that aren't as obvious. And that brings us to having to talk about here at the end, having to talk about the sum and difference of two cubes. I always loathe this part of teaching people to factor because sum and difference of two cubes, and I think it's partially because we're just at this stage burned out on factoring. And so at the bitter end, they start throwing things to memorize at us, and it can just feel like too much. And it often doesn't get enough time because you spend so much time learning to factor like we did in 6.6 and 6.5. So these are going to get the short end of the stick, and I don't know why I put a negative there. Okay. So sum and difference of two cubes. I had written them up on the board earlier so that all your memorized formulas would be together. These are sometimes, I don't think your book goes into this, which is really unfortunate, but I'll go into it. These formulas are sometimes called SOAP formulas. So this is an acronym that you can use to help you memorize. And the good thing about it is that it will help you memorize both of these formulas. So the acronym, the S stands for the word same. The O stands for the word opposite. The A stands for always. Otherwise, I can't make up my mind here whether to use capital letters or not. And the P stands for positive. Okay. Same, opposite, always, positive. And that is talking specifically about the positives and the negatives. So the S, the same, that refers to what I had mentioned earlier, where if you have A cubed plus B cubed, you have a positive there, the first sign you're going to write down will also be positive. If you have a negative and it's A cubed minus B cubed, the first sign you write down will also be a negative. Okay, and then the O, which stands for opposite, means that whatever sign you wrote down first, what am I doing? I was right. Was I right? I was right. Okay. So I wrote down, sorry about that. I am losing my mind today as usual. I took these guys and I reversed them. So I want to zoom up to the first time I wrote them down and see if talking and writing got to me there too. Same, opposite, always positive. Same, opposite. Nope, I was good the first time. The second time, it's like I've never heard of these. Okay, that's where the SOAP thing comes in handy. So same, opposite, there we go. Meaning that if you wrote down a positive between A and B, the next thing you write down is going to have to be a negative. If you wrote a negative between A and B, the next thing you write down is going to have to be a positive. And then the A and the P, the always positive part, that's going to go at the end because no matter what these formulas started out as, you're always going to have a plus B squared there at the end before the parentheses. So it's tricky. There's a lot hidden in there, but at least the A's and the B's, the A squareds, all of that is the same. If you took out the positives and negatives, you would have written the exact same line twice. So hopefully the SOAP thing will help you as it just helped me, because otherwise these can be really, really messy to memorize. Another thing that's worth noting, because in the middle of a problem, it can start looking like what I've got here in parentheses or what I've got here in parentheses should be able to be factored. This is a trinomial. It looks like a 6.6 or a 6.5 problem, but just be aware these will never end up being factorable. They're going to look like it, but they are guaranteed to be prime polynomials. Nothing else will come out of them. And of course, unfortunately, I have to scroll down past that, but I'm going to write the formulas that we need as we go along. So practice 6, starting out as basic as it gets with x cubed plus 64. So what we want is a cubed plus b cubed. So we're going to write down same sign, opposite sign, always positive sign. That's the formula we're going to be plugging into. And just like we did when we were having to do the difference of two squares, I'm going to take the time to rewrite this. 64 is actually 4 cubed. We're used to seeing 64 and thinking of it as h squared, which it is, but in a problem that is all about cubes, we want to go down one more level. 64 is a really special number because it can be somebody's perfect square, but it can also be somebody else's perfect cube here, which would be 4. So A is x, B is 4, and then very carefully I've got x squared minus A times B. The order that the formula gives it to you would have us writing x times 4. We can make that 4 times x, but I will, as we're new at this, put in an extra step, because the more steps, the safer we are. And then here at the end, to make it look more typical, more simplified, put a 4x there in the middle and a 16 at the end. Okay, now x squared minus 4x plus 16, that just begs to be factored, but it is not factorable. There's absolutely nothing we could ever hope to do to it. And to prove it to yourself, or if you forget and try to dive in and work it, you'll pretty quickly run into a wall. So this is, again, all about memorizing and not anything like the methods that we've been using. Okay, let's see, a little bit harder. Same page. A cubed plus 8b cubed. And boy, do I hate it when they do this. This is like the earlier problem. I think it might have been the problem I was working when you signed in, Valor, where the formula that we are taught to use has A and B, and then the actual problem has A and B. And that is just wrong. Okay, so same thing, same, opposite, always positive, making sure I got that right. I find this highly confusing, and maybe there's no good answer to that, but I'm going to say let x, I'm going to change some things around. Goodness, what am I touching here? There we go. Let me make this x cubed plus 8y cubed. And I'm trying to think of a good way to write that, and I wasn't finding one. So we'll just say we're going to change to x and y to avoid confusion. So x cubed minus 8y cubed. Now I'm trying to fit my formula. So this is like the quantity 2y to the third power. It's easy to see that x itself will turn out to be the a in my formula. And, you know, if it were not for that 8, then I could very easily say that y is b. But that 8 there requires me to break it down just a little bit farther and then be really, really careful as I place these in here. This problem is just so unfortunate on so many levels. So a squared minus a times b plus b squared. Anytime your a or your b consist of a number and a letter like smashed together by multiplication, you're probably going to end up wanting to have brackets so that you can use some little parentheses inside of there. But at the end, we can take away those brackets because we will simplify everything down, make it look much more normal, much more typical of how we see these things. And that would be the final answer. If you stumble across one of these in your homework, and when I write the homework up on the board in a minute, I will check. You are welcome to attempt it with the original A's and B's. The problem, the confusion that I was talking about avoiding is that if you do it the way they do it, you get something like A equals A and B equals 2B. And I find that just weird and wrong and unnecessarily confusing when we're just trying to learn a formula that's difficult anyway. Okay, let's see. Practice 8, this looks a lot better. So 27 minus y cubed. This time we are going off of the second formula. So same sign, opposite sign, always a positive sign at the end. So 27 minus y cubed. 27 is a perfect cube, as they call it. That means it is 3 to the third power, so 3 times 3 times 3 would give us 27. And what that says in the formula is we'll have 3 minus y. I know this looks backwards. We're used to seeing like y minus 3, but the way they've constructed the problem, we're not free to flip the order of a subtraction. So we just have to say, okay, this is a squared plus a times b plus b squared. That's 9 plus 3y plus y squared. Now, if it's just bugging you to death, the order of the addition here in the parentheses, you could switch that around, but why bother? There's nothing you can do about the subtractions, so we might as well just let the whole problem look weird together. And then finally, trying to decide how, okay, this isn't as weird as it looked. This is actually worthwhile. I was worried they were going to throw another one at us like they did a minute ago. So we've got b cubed x squared minus 8x squared. None of these other problems have had an overall GCF, but this one does. And it's x squared. So when we pull it out, it's going to be easy to forget about it. So this is b cubed minus 8. I'm going to go ahead and call that 8 2 cubed because the version of the formula that we're going to be using, which I neglected to write up here, is a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. So yeah, the 8 will be 2 cubed. And this is another unfortunate time. They use a b in here. And we're forced into saying something like a is equal to b. B is equal to 2. That's another one of those where I'm almost like, is it worth it to go ahead and switch out the variables to x and y? I'm going to plunge through it in this case. Just do my best. Sometimes it's good to call them first thing cubed and second thing cubed. So first thing minus second thing, first thing squared plus first thing times second thing plus second thing squared. It's just an exercise in like a brain bender. B squared plus switching the order of the multiplication because it's nicer looking, and then 4. And then the overall GCF. In this type of a problem, it was easier for me to just keep it out front all the way along because I didn't have this long multi-step method. It was more just plugging in, identifying a formula, plugging into the formula. Okay, now I said, yeah, let me, I'm gonna write the homework down because I did pick it before class today because I want to really look it over and make sure that, okay, and this is going to look like a lengthy list, unfortunately. These 4 optional formulas, the formulas at the very beginning of class are optional, so you can factor those like you would in 6.6. So you can look at it as just more 6.6 practice, or if the formulas appeal to you, you can use those. And then we've got the difference of 2 squares. Nothing weird there. Okay, so their choice of letters. These are a squared minus b squared, so they're pretty quick, just plugging into a formula. And then we get to the cubes, and this is where I'm really concerned. So plus minus plus, make sure it's balanced. A couple of these have overall GCFs. Yeah, that is as much as we need to do there. So a cubed plus b cubed, or a cubed minus b cubed. Okay, so there wasn't anything weird. They stayed away. Wait, nope. I'm blind. 25, I didn't even see that. This one, you may want to change to X's and Y's. Because that's where they've got A's and B's. Okay, I'm not seeing anything other, nothing really weird hiding in there. Yeah. I know that is a lot, but any questions about these new factoring formulas? The good news is that is the end of factoring, the end of the new factoring material. So just to reiterate what will happen when we get back after Thanksgiving, we will be doing, the book itself kind of anticipates this. They stick the review section for the factoring right after what we just did in 6.7. So we'll come back after Thanksgiving and we'll just plunge into their integrated review. Factor as many things as we can think of to factor just for practice, and then move on to 6.8, because 6.8 is the last thing we need before the test, but it's a lot. So I'm not anticipating passing out a test like right after we get back from Thanksgiving. So we'll just kind of see how things go, see how everybody's break went. Because I don't want you guys to have to feel like you have to study over break. That is not the point at all. So let me go ahead and try to save this recording and get it on YouTube. See if that works for me today. And I will send an email out with the homework, with the notes, just like always. And yeah, I hope you have a good, if you're not in church on Sunday, if you guys are going anywhere or not, but I'll either see you guys on Sunday or have a good holiday. Oh, wait, did you have a question?
I just said thank you so much for class today.
No problem.
I hope you have a good Thanksgiving.
Yeah, me too. It's a week.
We're gonna stay here. We're not going anywhere. So
Okay, yeah, same here. We're just partying at the house, so that's good.
thank you.
Okay, we'll see you later. Bye.